Okay, good evening, welcome. My name's Andrew Hardy. My day job is Infrastructure Services Lead at R3, which is a fintech company that runs a global permissioned blockchain for business to business and especially increasingly now tier one banking organizations for doing secure authenticated transactions. I was until 10 minutes ago chairman of the BCS DevSecOps expert group, and I'm a long-standing regular at the London DevOps meetings, which I do commend to any of you in the room who have an interest in DevOps. They are very good series of meetings, and we actually managed to have our first physical meeting of the year last month. So, what's the threat landscape? DevSecOps and supply chain integrity. Well, like weeds, the threats are everywhere and new ones keep popping up all the time. So how do you deal with something like this that's so random, so difficult and so threatening and get to sleep at night? There you go. Trust nothing, trust nobody. Check everything, check everyone, assume nothing. See, it's easy. I can go home now. But let's put a real scope on this. So, at least for here, I'm not going to talk here about direct attacks on running instances. That's out of scope. What supply chain integrity is about, it's all the way from code commit to your artifact repository. In other words, you have tested artifacts that are ready to be deployed at any time. So that's the CD bit of the CI. After that, that's down to your deployment code, your security, and so on for the running instances. Supply chain integrity is about the integrity of the deliverable, not the delivery of that deliverable into a running configuration. So everything from code commit to running production deployments, because you're going to be using infrastructure as code to do the deployment. All the code and tools you do to achieve that, that's your DevOps pipeline, your CI/CD pipeline. And the hardest bit, from a security perspective, is all the components you import from outside. Now that may be libraries that you incorporate into the artifact you are building and deploying. It may also be the components you use as part of that DevOps CI/CD pipeline. But not, as I said, a direct attacks on running instances. That's out of scope, but it's still a lot. So back to the meadow. Which plants do you not recognize? Which plants do you not want? Because as any good gardener will tell you, a weed is just a plant in the wrong place. Here's a good threat matrix. I put the URL in below to say where it all comes from. So you've got initial access. All the way across the top are the threats, and going down the columns are the issues that need to be guarded, thought about, protected, and so on. I'm not going to go through this line by line. This is a reference to read afterwards. I try to make my presentations readable as a standalone presentation file rather than putting in whizzy graphics and videos. And I'm no good at those. So who has access to the source repo code repository? This is beginning at the beginning. One of the biggest, hardest concepts I have found to get across to whisper it management when explaining DevOps, automation, CI/CD, and all of that, and especially infrastructure as code, in the everything as code world, you don't have people with root passwords logging into running things, fiddling with them and fixing them, because they shouldn't be able to log into them at all. It's the principle of immutable infrastructure. You don't fix something, you replace it. with a fixed version, not the same. All that code you define to create virtual machines, create Kubernetes clusters, deploy into them, configure them, and so on, runs as root necessarily. So trust shifts from that shared root password that the ops chaps log into the running instances to who has access to the code that will run as root. So are you controlling write access to your infrastructure as code repos tightly enough? Lots of processes are going to need read-only access because if it's infrastructure as code, every time you do a deployment, the pipeline runner is going to need to read that code to know what to do. And can you prove to the system who those users are? The ones with the right access. That's about your access security to your repository. Do you have a hardware token like a YubiKey or something? Do you have signed tags, commits, and merges? Why do you want this? Well, that proves it was that person who did that tag, commit, or merge. Do you have protected branches to enforce the rules? So if you have protected branch in Git, you can control and limit what happens to and with the code in that branch. Timestamping, this is the one people very often forget. If the timestamps can be perverted, you can change history, of course, and cover your tracks as a hacker. So you've got a code commit or merge, now what? Well, you've got the third-party components problem I mentioned earlier, the stuff you import either to make the artifact or to promote it on the route to live. And the local trust problem. The SolarWinds hack was very famous and most people have heard of it, but I'm not sure if most people have heard about how it worked. In the SolarWinds hack, they had a dormant component that they managed to insert into the system that watched and looked for things. And what it found was, in the SolarWinds pipeline, at an early stage in the pipeline, a temporary local file was created. That local file was then incorporated into the pipe stream, into the pipeline several steps later. So they compromised that temporary file because the pipeline assumed that as the pipeline had made it, it must be safe. It wasn't, because that file wasn't protected and wasn't checksummed or hashed. That's how the SolarWinds hack worked. Modern code relies heavily on third-party libraries and plugins. I keep seeing figures that 75%, 80% of applications these days are all libraries. Many of them now are little more than some business logic applied on top of the libraries that provide the real functionality. And the richer the functionality these imported libraries provide or contain, the bigger the risk. The build process incorporates those components into the artifact build. And it's very hard to determine a priori whether they're safe or not. You have to rely on the reported vulnerability discoveries, your CVE libraries. They are, of course, your big friend when you're doing all this. So you've got security in the build components. Now, what about the tools you're actually using to run the build, package, and deploy process? Can you be sure that the tools haven't been compromised? Because, you know, you're downloading these from somewhere. They could have been compromised at source. Do you use the signatures to verify the binaries? Most places put out checksums or SHA-256s or something, so you can make sure the binary is what you think it is, or has not been modified more accurately. And do you use the source code protection principles, which I described earlier, like protected branches, signed commits, and so on? Do you use that for your pipeline code as well? Because you should. If you're making a binary or a library or runtime code like a Java jar, that's about as far as you can go to ensure the artifact integrity, because it doesn't contain anything else. However, many people nowadays are doing containers, Docker, and putting that into Kubernetes. Well, a container, of course, brings its own third-party components because it's a layer, layers, multiple layers. Your container can have 10, 12, 15 layers, all of which can have a different origin. You have to do a CVE check of all the imported layers. One trick that can be brought to play here, which is used by the US Defense Department on their container platform, is the lowest level container. When you're writing a Docker file, you start with the word from, and what you specify there is the lowest level base container is the most important. So what the US Defense Department does is you strip out that base layer and replace it with a base layer you know is clean. This works because you can change the composition of the layers in containers. So now you've got artifacts you're confident of. Now, remember the mantra about artifact repository, only tested artifacts that are ready to be run at any time. Now you have to add, they're not only tested functionally, but are security assured by some of the measures that I mentioned earlier. But that's assured at the time they were built. You have to keep checking them because the CVE is not a functional warning about something bad in the code. It's a report that someone found something bad in the code. So you may import a component that does not have any CVEs at the time you import it, but a CVE may emerge later relating to that component that is now incorporated into your artifact. So either you have to keep checking all your artifacts, or you keep running the build pipeline with the checks included to see if it passes as far as a built artifact without a CVE being detected. So now you've got to deploy these tested and security assured components. But that's code as well. So you have all the same concerns for the code of the artifact's functionality and the code in the tool chain that got it as far as a deployable artifact. Now you have environments to worry about and policy. Some of this is the protected branches can do some of this as far as creating artifacts is concerned. But for your deployment, you have to be able to ask the question, which processes are allowed to deploy which artifacts into which environment? And at this stage, that's not going to be a human actor. We've moved past point and click to do deployments. This is going to be an automated process. Now, I accept that in some operating environments like banking and fintech and, as we were talking earlier, safety critical, a manual approval and sign in blood and the audit register is necessary at some stage. But by and large, this is automated because you want speed. One of the whole purposes of DevOps is speed through automation to give you repeatable, reliable build, package, and deliver processes. Because if you have immutable infrastructure, you're not going to fix something if there's something wrong with it. Hot fixes disappear. You have hot deployments instead, where you deploy the new fixed version that replaces the old broken version. That's why you need this pipeline to be fast. So now your code's running in some random environment, and now you've got to move it towards production. How will you do environment promotion? Will it even look like the environment promotion you're used to, which is you take on the principle of build and test once, promote unchanged? You're not going to be taking an artifact and copying it or pulling it into a higher environment, not with immutable infrastructure. So many of you would have come across the notion of GitOps. Well, GitOps is a notion created by Weaveworks, which was if you have infrastructure as code that defines all your environments, dev, staging, pre-prod, prod, whatever, then the only difference between those environments, in fact, is differences in the metadata that defined their creation. So the principle of GitOps is environment promotion is a pull request that changes the metadata from dev to staging, for example. And in an automated system, approving that pull request triggers the creation of a new staging environment, because it's all infrastructure as code, deploying the tested and security assured artifacts into it, and using that deployment to replace the previous deployment. Now, those pull requests can be automatic, or if you need that final manual approval step, then it's just a manual approval of the pull request. So, finally, you've got securing access to the target environments to make sure that remote processes can't deploy stuff into your higher environments, and that any actors, human or non-human, can be verified tightly for deployments. So now you've got it production as carefully as you could. Happy now? Not hardly. As I said, remember that CVE reports are at a point in time. Things can change. You've got to rescan your artifact repository, and if a new CVE shows up, where is that affected component running? Which repos, which environments, which functionalities, which applications are affected? Here are some similar parallel problems. If a third-party component author or their repository is compromised, where are those components? Are they running, or are they in an intermediate artifact somewhere hiding up your route to live? Are they an artifact ready to be deployed to staging but have not yet reached production? And what about if suspicion falls upon one of your own staff? Remember, many hacks and compromises are inside jobs. And if you've deployed any of that possibly tainted code to a client environment, because you're doing deployments to target environments that are not yours but belong to the client, now what? Observability. Observability it's another term adopted by the computer industry that has varied and misinterpreted meanings, a bit like agile. Observability is not just logs and metrics. Observability is far more than that, and it's a big topic way beyond here, but it includes all kinds of things to give you visibility into what's happening, because with containers and Kubernetes, and even more with things like service meshes, they are black boxes. You can't log into them and fiddle around and look around. You know what they're doing only by what they tell you they're doing or what you ask them they're doing. That's the difference. So what we need here is a tool that can keep an audit trail of code authors, components, suppliers, intermediate repositories, and so on, right the way through your CI/CD pipeline to live production. Anyone know one? Because I don't. I'm still looking for one because it's a very intractable problem. Now, carefully crafted log entries could be the answer with rich tagging. Now, tags are a very underused thing. Tags are basically cost-free, and they're a way of annotating lots more things than just your VMs, which is mostly what you see people use tags for. When they create VMs or Kubernetes clusters, they'll put a few tags on there to say who did it and when it might be able to be safely deleted and stuff like that. But rich tagging can provide the kind of metadata that can help you with this problem. So your next headache, as I said, if you are delivering this stuff to clients, they want to be confident you've done your best to ensure and verify what you've delivered them. And you want to be sure you have and that they're confident in what you've done. The people who had SolarWinds were confident that SolarWinds were doing their job. Now, it's hard to do all this alone because of those third-party components. How do you deal with the upstream long tail all the way back to the origins? It's time to have a look outside now at what's going on in the world to address these problems, both at a kind of official level and at the community open source level. And there's a huge amount going on in the open source level. And there was a survey that came out about 2 or 3 months ago that said people are now firmly focused on open source tools for dealing with security and supply chain integrity and so on, because they like that comfort of it being an open source tool that many people are using and looking at, and that the source code can be examined and validated. So, did you know April was National Supply Chain Integrity Month? I confess I didn't. It came just 4 months after the SolarWinds attack, and actually last year in February, the FBI warned about upcoming supply chain integrity attacks. So CISA, the US Cybersecurity Agency, Department of Homeland Security, CDSE, and very confusingly, America has an NCSC, which is different from our NCSC. But those 4 agencies participated in National Supply Chain Integrity Month. And our NCSC has shifted its focus from practicalities to principles. In other words, not what you should do, but the principles which you should employ. Now, I'm not quite clear why they've changed that, but of course, principles are easier to maintain than practicalities, which have to be maintained and updated constantly. So what about the initiatives that are going on out there? So, have any of you heard of SigStore? This is a standard developed by Google, Red Hat. Google and Red Hat, of course, are now one company, and they're doing, it has to be said, they're doing a lot of very good stuff in the open source space. Linux Foundation, which of course also does great work. Purdue University provided, I suppose, the academic input into this. So this is a way of doing a standardized signing, verifying procedure on software artifacts. And over to the right, I've included the bit about tamper-resistant timestamps. Bearing in mind what I mentioned earlier, if you can fiddle with timestamps, you can cause a lot of problems and do a lot of bad things. So that's one thing. What about elsewhere? In Toto's a wider framework that can apply to much more of the supply chain tool chain. So it's quite a few interesting names that are collaborating in there. Git itself, Debian, Docker, SUSE, Datadog. And it's supported by 3 of the major research associations in America. Then there's TUF, the update framework. This one aims to secure software updating, and it provides protection even against attackers that have compromised the repository or the signing keys. That's very interesting, because if you can compromise the repository and fiddle with the signing keys as well as the artifacts, of course, you as the downstream user cannot detect that those artifacts have been compromised. Managed by the Linux Foundation and CNCF. CNCF, the Cloud Native Computing Foundation, are doing so much good work now. After a shaky start when they began, they're doing some excellent work. Those two can work together, and which could provide a very powerful framework for dealing with this if you are delivering software updates to clients. Google, a new initiative from Google called SALSA, Supply Chain Levels for Software Artifacts. It's provenance. So this is what's used in supply chain or based blockchain systems, for example, for providing provenance of delivered goods from, coming out the factory door or even earlier to arriving at your door by the means of a series of attestation steps. An attestation is nothing more than a cryptographic claim of something, but a provable one. So this is, I confess I have not read deeply into this one because it's fairly new and I didn't have time, But it's interesting that what it's doing is the same thing or similar to what's being used, for example, in food chain, supply chain integrity, where you're interested in, organic produce, for example, and it's also being used in medicines for supply chain. And I believe I read somewhere that it's being used for cold chain. That's where you have vaccines that have to be kept cold all the way from production, right the way through to just before you use them. And that's being used for that. So this is an interesting thing where you've got actual practical in-use systems being applied back to the software process, where those processes were not being used for software, but for other things. Okay, if you want to look at something, this first document is absolutely the best document out there. And it's a CNCF one, and it's an excellent piece of work. 45 pages of great advice that if you are concerned about supply chain integrity, you should read. The NCSC guidance I mentioned earlier, which is these 12 principles, but not information on how to achieve those principles, how to apply them. And CISA in America has, this is just a 2-page flyer, but it's the kind of thing to use when you're making the case to whisper it management for the resources you need in order to do supply chain integrity practices that I've described here, because this is an expensive process. It's not just buy a faster machine or something. It's an expensive process, it requires organizational change as well, because of the shifting responsibilities. And organizational change is always hard to get approved. So that's a very good 2-page flyer that will help provide support for business case or resource requests or whatever within your company or organization. This CNCF also do this technology radar, which is, again, just a report of a point in time, not a prediction about tools you're going to use. What it's showing here is tools that people are using this year, well, as of September, in this process. A lot of familiar names in there, 1 or 2 names that might be less familiar to you. But in the bottom, in the adopt, most of those are well-known names. Some of you may not have heard of OPA, that's another CNCF, Open Policy Agent. What this does is you define policy separately from its application, and you can define it in a source code repository. And then it's applied where it's needed. So you'll have one policy that might have 15 or 20 processes that reference it before providing access or permission to perform some action. This is rather more sophisticated and with better granularity than Azure Groups, which is what most people seem to use. And everyone knows that groups of groups doesn't work properly. So Argo CD, Terraform, HashiCorp Vault, Calico, Artifactory, SonarQube, Istio, these are all well-known. Istio's the service mesh is very complicated, but it's becoming pretty well known. And most of the other names there are familiar to all of you. So are we there yet? Well, not quite, we're getting close. There's no end point here, it's a journey, there's no end, there's no destination. It's an ever-going, ongoing battle. It's like threat and counter-threat. You're having to also project security and assurance outside your own boundaries. If you are delivering artifacts to customers or providing services to clients, that's outside your own boundary. And it's so many things to consider on top of all the normal IT security stuff. And if you're in the fintech world, there's an awful lot of that. DSS, SOC 1, SOC 2, and so on and so on. This stuff is complicated. So my head hurts after all that, and I feel like lying down in this warm meadow with the sun on my face. This warm meadow is in fact in Romania, which is where I took this picture. Obviously not now in December, but a few summers ago. So that's it. That's my presentation, and I'm happy to take questions if you have any. That's it. Thank you.
Okay, thank you, David. Thank you very much. Let's go through some questions. A couple came in. I'll just come around the front so you haven't got this disembodied voice. So.
Oh yes, sorry, in the chat. Yes, it's IBM that owns Red Hat, not Google.
Yeah.
But the two of them do collaborate extensively on a lot of these open source tools, especially around containers, Kubernetes, and DevOps. Yes, I am going to send Roy the slides, and he will do the necessary to ensure that they're available. Okay, real questions now. Either in the chat or speak.
So I had a couple of questions I noted, David, but before I do that, see if there's anyone in the room that's got any questions. No? No, okay. You mentioned a term, infrastructure as code. If people haven't come across that before, have you got a way of just explaining what that is, perhaps?
Sure. In the good old days, when you had bare metal servers, and then when the cloud virtual machines came along, which is just someone else's tin, really, your configuration was done largely by hand. You'd install stuff, you'd configure stuff, and so on, and it would be done manually, maybe help with a few shell scripts here or there. Now, obviously, if it's a manual process, it's prone to error and mistakes. And also, a few shell scripts, the logic and the code is all separated, it's disjointed. But the idea of infrastructure as code is to define in code, in your version controlled repository, the steps necessary to create the infrastructure you want. Now, that may or may not be procedural, and it may or may not be declarative, or it may be both, depending on the tools you're using. For example, if you're creating virtual machines, that's going to be declarative. You will run a cloud command, AZ, AWS, to create a VM, and then you'll use a tool like Ansible, maybe, to automate the configuration of that deployed machine and install things on it. That's procedural. Kubernetes is different. In Kubernetes, you don't tell it, I make me 10. You go, I want 10, and it makes 10, and it keeps it at 10. So the code is declarative, nearly always YAML or HashiCorp's language, which is a kind of cross between YAML and JSON. That there's no procedural steps in there. Do this, then that, then something else. It's just declarative. Now, if you have all of your infrastructure, your environment, if you wish, defined in code, not only can you look at that code in one place to see everything, but it's version controlled. It's changed by pull request, and those pull requests will be approved or rejected. But also, every time you do a merge, you've created a waypoint. You can go back to a previous merge and recreate the old version of the infrastructure for some reason, if you want to, for running comparison tests with the current version, for example. But the point is, the whole thing is fully visible and fully audited. And the fact that it's all as code means it can all be automated, whereas those manual processes cannot. My imperious aphorism about this to people who work with me is GUIs are for looking, not for doing. You should not be clicking around in a GUI to create a Kubernetes cluster. You should be doing that as infrastructure as code, but it's perfectly acceptable to use the GUI to then go in and have a look to make sure you got what you wanted. That's it. So that's what infrastructure as code is all about. It means you're not just having the code in the application, but in all the tool chain that's used to build, package, store, deploy, and eventually delete running instances of that artifact. That's it.
Okay, thank you very much. Does anyone else want to ask anything about, any more about infrastructure as code? Okay, that's a great explanation. Thank you very much, Andrew. The other thing I noted was you mentioned the term immutable infrastructure a couple of times, and I think you hinted at it, but could you explain?
Yes. This is colloquially, this is referred to as cattle, not pets. Which means if your running instance is sick, you don't take it to the vet and make it better. It's cattle. You kill it off, and you make a new one. So you don't modify running code. The data that running instance may be working with may change. That's fine. That's normal. But the code doesn't. The deployment and the code and the configuration of that deployment and code doesn't change, except for dynamic things like load sharing and that stuff. But in application terms, it doesn't change. If you have a problem or you just want to do an update or not just fix a bug, you make a new one and replace the old one using techniques such as blue-green deployment, where you simply switch from the old version to the new version. And if things don't go too well, you can switch back to the old version. That, of course, is a very blunt instrument, because it affects all of your requests, e.g. API requests to that code. So what people tend to use nowadays is what's called canary releasing, where in your API or in your API load balancer or reverse proxy or service mesh, you arrange for, say, 10% of the incoming requests to go to the new version and 90% of the requests go to the old version. That way, if something's wrong with the new version, only 10% of your customers are annoyed and 90% are still happy. Now, in Kubernetes, you can do cunning things with this, assisted by service meshes, which is a progressive canary rollout where you instrument how the new version is going. So you do the 10%, and if the new version is going okay, you'll do another 10%, and so on until you get to 100%. But if some KPI that you've defined is not met at any stage in that process, you progressively roll back to the old version. So it's not red, blue, green, it's progressive. And you can make that progression as small or as large as you like, depending on the severity of the release you're trying to do. Another trick that you may not have heard of that you can do with service meshes is called dark canary. And what you do in dark canary is inbound requests. I'm talking in all these cases about API because it's APIs and microservices and all that kind of thing. In dark canary, what you do is you replicate the incoming request and send it to both the old version and the new version, but only the old version answers. The theory here is you're testing the new version to make sure it doesn't break on any of the inbound requests. So what you might do is you might do a dark canary first and then a progressive canary as a way of rolling out a new version into production. That's it. Okay, thank you very much, and thank you for introducing a few more animals into the because I mean certainly the where are we, the cattle and pets one I had before, and it's good to hear about the canaries of different colours. Yes. I don't know of any other animals involved in this. No, that's good. Okay, any more questions? Okay, let's just looking at the chat. Yes, somebody mentioned one about software bill of materials. I haven't mentioned software bill of materials, but it does come into, I think, the tough framework that I mentioned. I mean, the software bill of materials is no different really from a manifest. Manifests have been around for a long time. Okay, so you're saying it's the same as a manifest? It's similar. Or very similar, yeah. Similar. I mean, a manifest is just a list of names and numbers, really. A software bill of materials might have more things. But what you really want to know is what components are there and what version they are. That's the basic fundamentals you should not avoid. Now, that could be in your, it could be in a Maven definition, or it could be part of the list of imported components. What you want in the end is something that describes or as I mentioned with Docker containers, a list of the layers and versions that are in there so that you know what components are in there and what version they are, because that's what you need if a CVE is flagged up for one of those components in that version.
Okay, thank you. Do you want to comment on the Cybersecurity Act, Andrew, that Anthony mentioned?
Well, yes, and there was this thing that came out well, it was not only that, but it was also about zero trust. Now, zero trust is another whole thing, probably worthy of a presentation in its own right. Many organizations still operate with the kind of hard shell, soft center approach called a corporate VPN, where you access your company's network via a VPN and then have pretty much wide access to the corporate network. This is kind of being regarded as an out-of-date model. Sorry, Cisco, but things are moving towards a more nuanced approach, which is what zero trust is about, where what you're doing is you're validating access from an entity or an actor or an endpoint to everything that it can access. And so zero trust is a black cat in a coal cellar. You can broadcast as much discovery stuff as you like, which of course is what threat actors do. If they manage to get onto your network, they will start doing scanning of the network to discover endpoints and ones that might be vulnerable. In a zero trust network, no endpoint answers unless you present it with the right crypto key. Unless you know Open Sesame and the password, the endpoint doesn't answer. So you can't discover things by doing scanning. Now, zero trust is it's a great idea, but it's another non-trivial thing. It's quite complex to do this, and much of this is not open source. It's vendor specific stuff, as many access control security tools are. But zero trust was mandated as one of the techniques for the cybersecurity by, I think it was a presidential decree, wasn't it, that got signed after the SolarWinds thing. And zero trust was one of the big things in it, because zero trust principles can be used to address a lot of the vulnerabilities I mentioned in the presentation when it comes to accessing code, repositories, and tool chains. That's it.
Okay, thank you very much. Let's see if there's anything else. No, that's sort of where we are at the moment. Anything else? Nothing else from the people in the room? Okay. Anything else you wanted to add, Andrew?
No, I think that covers it. I'm happy to take questions later by email or offline means. But I think what I hope those of you who listen to my presentation will go away with is a bit of an understanding of the things you need to think about rather than the specific techniques about how to deal with them. Because some of this stuff is kind of dark to most, a lot of developers are just not that aware of what happened downstream, or even what happens upstream from them.
Okay, all right. Well, look, thank you very much. And for those in the room and for those remotely, we'll just give Andrew a quick round of applause. So thank you very much.
Thank you.